Hello, everybody. So thanks for joining. Today we're going to talk about, as you can see, most common vulnerabilities in GitHub Actions. We'll try to understand what they are and how to protect against them. Yeah, let's do it. Let me quickly take a sip. This is vodka, by the way. Just kidding. As I mentioned earlier, maybe some of you didn't see, there is a QR code. While I go through agenda, you can use this QR code to download all the slides. If you can't wait, if you want to like click all the links that I'm going to use, etc., etc. I will also repeat this QR code at the very end. The slides will also be provided by some other way. I think maybe they will be sent in the Slack channel or in the email, as well as the recording will be available on YouTube after that. So if you need this information, you will be able to return to it very easily, so no worries about that. All right, so the plan for today, because this is a webinar about GitHub Actions, I assume that you already know what GitHub Actions are. I hope you use them, that's why you want to protect them, but I still decided to have a little very quick one-on-one introduction into GitHub Actions, just to make sure that we are on the same page and use the same terminology. Then we will move to the main topic, to the vulnerabilities. We'll talk about them, we'll see how they look like. Then we'll talk a little bit about how we can harden our workflows, not to let the vulnerabilities happen. Yeah, and discuss how to find those vulnerabilities as well. Okay, let's move on. This is me. My name is Vasily Yermilov. I do security research at Semgrep. I'm interested in everything around static analysis, SaaS tools, and yeah, I keen on bug hunting automation, specifically on big scale, big scope. The bigger, the better. I like to scan like thousands of code bases to find vulnerabilities as effective as possible. If you want to reach out, there is an email. There is also a website where you can find all the links to like social media if you want to reach out through other ways. So let's go. Let's do very quick one-on-one. So GitHub Actions. GitHub Actions is the CI/CD platform. It allows us to automate different activities on the code base, like build code, test code, release, do all this stuff that other CI/CD platforms do. And GitHub Actions, they are driven by such thing as the workflow, by workflows. On a very low level, workflow, like one single workflow, is a file, YAML file, YAML configuration file that resides in the .github/workflows directory. This is how the typical folder structure look like. This is how the typical workflow look like. It's a YAML file with the configuration of the workflow. What's inside? On a higher level, we can look at this way. So every single workflow is triggered by the event. Such events can be pull request, maybe comment on the pull request, on the issue, fork, cron schedule, etc., etc. So there is like a big list of events that can trigger a workflow. When the workflow is triggered, we have runners. Each runner consists of jobs. You can think of these jobs as like separate machines, so it's like separate environment, and each job consists of steps. And so single step is the main entity of this whole system. Step is where you define what you exactly want to do, like run a bash command, run another GitHub action or a script. And jobs is the way to put these steps into a particular order. In real world, it looks something like this. We have an event. In this case, we have pull request. So on pull request, this workflow is triggered. Its name is my workflow. It has jobs, one job, in this case, its ID my job one, name hello world, and we have steps. In this case, we have one step that is echoing hello world to the console. As simple as this is pretty much it with the one-on-one. Let's see the potential attack surface of such workflows. Give me a second. So this is not like this picture, and what I'm going to say is not something concrete or something that I get from reliable sources. This is just my personal opinion, and I believe that potential attack surface can be much bigger if we go deep into this topic. But in general, as a high-level overview, we have the workflows, and we have two potential scenarios. So we can have either our workflow written by us or by people from our organization, our developers, and this workflow can have certain bugs and certain misconceptions, vulnerabilities that can lead to potential exploitation, or not potential, so they can be hacked. On the other hand, the other case is when we use third-party GitHub Actions, they can be potentially compromised or hacked, or attackers can identify vulnerabilities in them and use it to exploit our organization in turn. Those things, like, both have its risks, both important. For this presentation, for our webinar, we will focus only on the first part, on the vulnerabilities that can be introduced by us, by our developers. And since the second part, well, it's also very important, but it's more like a supply chain risk, and it just goes beyond the scope of this presentation. Yes, and before we jump into the first vulnerability, let me know if you have questions. By the way, yes, while we go, I will stop during each chapter, so feel free to ask something, like if you want to clarify or if you have questions, yeah, and I will try to answer. So far looks like everything's okay. Let's continue. So let's see the first vulnerability. Okay, what we see here is a simple example of the workflow. What it is doing, we have the workflow that is triggered on issue opened or reopened. So we have a publicly available repository. Somebody goes into the issues, open the issue, and then this workflow is triggered. We have one job. This job have one step. And what we see here, that it is echoing something to the console. What is it? When you see curly braces with a dollar sign, it means that like a value is inserted in this part of the configuration. You can treat it as templating in web applications. It's very similar to this. So this value is first inserted, and then it is after that evaluated as a command afterwards. So what we see here is the GitHub object. So every workflow is supplied with this information about the context of the workflow and the event that triggered this workflow. In this case, what we have is that we have the issue as the trigger, and we have we can use information about the issue. In this particular example, the issue title. As some of you might guess that when we put issue title into this bash command and use it as a part of the command, user who opens this issue can manipulate the title and put basically any kind of input there, and it is in full control of a user. And it can turn, let's say, into something like this. This is the example of potential way of stealing a token. Let's say there is a secret token, service secret, and we try to leak it to our server. So in this case, the title becomes the part of the bash command, and it turns basically into a straightforward OS command injection. where this situation can happen? In many places. So basically, wherever you see the injection point, the curly braces, potentially there can be like a vulnerability. First of all, it's when it's inserted into the bash commands, into this run parameter. There is also a very popular action for running JavaScript. And by the way, not only JavaScript, like this one is the most popular, but I saw Python. Also, there can be many custom, less known actions that also can run scripts, and any kind of injection here will mean that you have some sort of the code injection, but it will work the same as the OS command injection. You will be able to like run whatever command inside the environment like that you want. Also, quite often nowadays, I see that there are custom actions that wrap. This is just an example, but they wrap, for example, well-known tools, command line tools, into a separate GitHub action. And what they do, they allow you to pass all the arguments to the command line tool that you usually use as a parameter. And then many times I saw that they, inside this custom action, they evaluate, they just concatenate the string together and evaluate it, meaning that if you can provide, if you can control this part of the arguments, you can basically do this the very same thing as here. So, but it's not like the full list. You need to be creative about it. So it can happen in many other places as well. But this is, I would say, the most common. Okay. We have the injection. So let's say we can run arbitrary commands. You may wonder, like, so what's the big deal? What's the problem here? We will talk about the full, let's say, list of potential impact in a second. But before doing that, I wanted to like clarify one thing, that when the workflow is triggered, the jobs start to work, they initiate it, and each job receives GitHub token. Such GitHub token, this is the example how it looks like. Such GitHub token is used for each job to communicate with the GitHub API. And if we try to steal it, or if we successfully steal this token, we can act on behalf of the workflow. So we can talk to the GitHub API as we are the workflow of this repository, of this organization, and do, well, potentially malicious activities, like we can submit the code, read some metadata, etc., etc. Also worth mentioning that each event that triggers the workflow by default has different set of permissions that are given to the token and to the workflow specifically. For example, if we have the workflow that is triggered on the pull request from the external fork, by default, everything is fine. We have only read-only permissions. Nothing really serious, especially if we talk about public repository, what you can read the contents, you can read the pull request. I mean, you can do it anyway, so it's not impactful at all. On the other hand, there is another type of event called pull request target. If you use this one, by default, GitHub token has all the right permissions. And these two, for example, give you the rights to create pull request, approve pull request, and basically submit any code without interacting with the owners of the code, with developers, and like submit the code in the start mode, and do many other malicious activities. So the combination of the event, its GitHub token permissions, and default configuration for this event is very crucial for understanding the impact and understanding if workflow is like even worth hacking or not, or like is it protected enough or not. And this is the table from a very good cheat sheet. I provide the link to it, where like this is described basically like in the form of the table, what I was talking about before. So yeah, feel free to refer to it. And now time to kind of wrap it up into like what potential impact can attacker gain. So first thing, we have the command injection, we can execute the code inside our workflow, right? So as for me, just the fact that we can execute the code inside the workflow, just this fact is not necessarily like a high impact or a big problem. Because what can we do? Like, okay, we can run arbitrary code. It looks more like a problem of the GitHub rather than organization, because, well, what potentially we can run maybe Bitcoin miner, or I don't know, like potentially there is like opportunity to do such thing as a denial of wallet, because GitHub Actions can cost money if you run a lot of them and you have like a paid subscription. You can write a lot of them, very heavy. Potentially it can like do a damage in terms of like get like using resources, but it's quite easy to identify and as for me easy to mitigate. So the fact that you can run arbitrary code in the workflow, it's not such a big deal. But as we talked earlier, there is a very lucrative target, which is GitHub token. If the attacker can extract it, the attacker can potentially act on behalf of this workflow and push code to the repository, create releases, maybe run other workflows that in order have their own like vulnerabilities or other permissions. So do different kinds of malicious activities. Also, there is a potential danger that attacker can try to steal different credentials that are used inside the workflow or secrets that are provided to this workflow. And well, depending on the importance of those credentials and secrets, this may be like even more impactful than the compromise of the whole workflow. So yeah, this is the potential impact that can happen. Let's talk about how to remove it and how to mitigate this danger in our GitHub organization. So it's quite easy. This is the same example that I showed you previously. We have a workflow that runs on the issue. When it's open, reopen. We have the injection. We use this title here. How we get rid of this injection? Very simple. We just move the value to the environment variable and use the environment variable inside our command. We can do the same inside our script. We just would need to like extract the value programmatically inside the script and be good to go. So as simple as this, just by doing that, we removed the whole like vulnerability type. Okay, let's see what we should learn from this part. Use a controllable input, such as like issue title, branch name, maybe a comment to the PR or the issue should be treated as the source of potentially dangerous input. The sink will be tabs that run commands or execute code, such as bash commands, run script action, and many others. So be cautious about it. How to mitigate? Use the environment variables. That's the way to do it. Okay, this is the end of the first chapter. Let's see. Do you have any questions? Anybody wants to ask something? Okay, let's move on. Give me a second. Right. Okay, we see some GitHub token is on the valid during the execution of the workflow, right? So in the case, yes, GitHub token. So the question is that GitHub token is only valid during the execution of the workflow. This is true. But let's say when we have a command execution, what we can do, we can just run sleep and like a delay. So what we can do, we can extract the token, then just try to delay the execution of the workflow because we control the what's going on in the workflow. And like I was, when I was hacking the workflows, trying all this thing out, I was like giving myself like 30 minutes because I'm very clumsy. Like I was like extracting the workflow, sending like it to the one place, resending it because I did it wrong, so etc. etc. And usually I don't remember like how long is the default execution of the GitHub workflow, GitHub action. I think it's like 1 hour. So it should be more than enough to do all the malicious activities. So okay. let's see. Okay, if you have other questions, feel free to put it in the chat. I will return to them after the next chapter. So the next vulnerability is, I call it executing checked out code. Maybe there is a more like a better name for it. I don't know. Anyways, so what is going on here? It's an interesting concept. I think slightly different from what we see in like traditional web application hacking. So GitHub is a CI/CD platform, and that is used to like perform different activities on the code base, right? So we want to like test it, maybe create, like build it, create different artifacts from it. But what if the code that we use or want to work with is supplied to us by somebody else, like by a third party, like in the simple case, the pull request is opened by a user who found like a bug or something, or just wants to provide a feature to us. So this code can potentially be dangerous. For example, let's see, we have this workflow. What's going on here? We have a workflow that is triggered on the pull request. It checks out, so it uses action checkout GitHub action that takes the code that was submitted in the pull request and then run npm install on it. Or for example, if it's not JavaScript, it can be whatever like else, like Composer for PHP, Python install for Python, many other things. So it runs package install, like package manager install. It looks innocent, right? But it is not, because potentially the user can submit in the pull request, in the case of npm, the package.json, modified package.json with the pre-install script that will be executed before the installation. So basically can inject its own scripts that will be executed inside the pipeline. What potential impact can be acquired here? Basically the same. So the same as we talked before, it's just will be achieved in a slightly different like approach. So in first case, we had the injection point. Here we have the code that we submit and that it gets executed. Yeah, but basically the deal afterwards will be the same. We will try to achieve the same goals. The problem here is that it's quite hard sometimes to identify such things because there are many ways how the code can be checked out, can be used inside the workflow. This one is the most popular. I believe that maybe safe to say that maybe half of the workflows on GitHub, on the whole GitHub, use this because it's like the common way to do it, but it's not the only one. So we can just use the bash command and like do the git straightforwardly. We can use the API and we can use some custom actions. I don't know. So many ways to do it. So sometimes it can be hard to identify, and also many ways to execute code. So it's always possible to, I think, inject some scripts when we use module package dependency managers like npm, Maven. There's a multitude of them for all like modern languages. We can modify unit tests or other tests, so different tests. Also, usually when the code is built or some part of code is built, like different make files, build scripts, so and many other things that I can even think of. So it's a you need to be creative, yeah, to identify those things. As a little side note, I wanted to mention, because I showed that actions checkout is one of the most popular ways of getting the code. And it also turns out that by default, such action stores the GitHub token on the file system. It's needed for communication with the Git. And if you have an injection, or you can execute arbitrary code inside the workflow, you just need to read the file on the file system to extract this GitHub token. There is an example command that sends it, extracts this git config and sends it to the server. Then you can extract the token. and use it. On top of that, also as a little like side note, that not only this action, but also there is a lot of them, like everything that you like. I know Azure, Jira, Google, so they store by default their credentials on the file system, and yeah, it can be a lucrative target for attackers as well. So you can see more in the cheat sheet. So it was like a little side note. Now let's talk a little bit how to mitigate such situations. So let's say we want to we need to act on the code that is submitted by a third party. How do we protect in this case? So let's say like in this example, what we want to do, we want to check out the code, run npm install on it, and then run a script that will reason should we approve the PR or not. Such PR, like such activity, requires write permissions for pull requests, but we don't want to expose it to this part. What we would do in this case, we separate the steps into two different jobs. We want all the activities on code that can be like that can execute third-party code to be run in the job that has only read-only permissions. Like for example, here we like move it to the job. We call it build. We get the code, run npm install, but the permissions are read-only. As we showed before, it's basically no impact, no point in like trying to like run any code on this. And when we do all the activities we want, then we can use, I omitted here in the example, but we can like, if you want a compiled code, do something with it, we can turn it into an artifact and pass it to another job. Or if we just need like if, else, true, false, we can write it as an output or write some value as an output and read it in another job, which in turn is using like a higher permissions, those that are required to finalize what you want to do, like approve the PR in this case. So we will approve this PR with the right permissions to do it, but we like the code execution will happen in a safe place. So yeah, that's my suggestion how to mitigate it. Work with the code inside the separate job that has minimal permissions, read-only permissions, then use the result in another job with permissions that you actually need. Okay, what we should learn so far? No trust to the code that is submitted by user. Compiling, running user's code equals RCE, remote code executions, many type GitHub tokens like are stored on the file system. Well, and mitigation, we just looked at it like run the code only inside the job with read-only permissions. Let's move on. So, okay, I saw some questions. Let me quickly check it out. In cases. Yeah, this is a good questions about on-prem. We will talk about it right now in the next chapter. So yeah, good timing. Let me quickly return to my window. So yeah, what's the next potential danger? Is self-hosted runners. The same thing will be true about on-prem GitHub. So what GitHub allows you to do, even if you use just not on-prem, but the general GitHub website, it will allow you to potentially configure your workflows to run on your infrastructure that you rent or you own, whatever, by setting up, well, you would need to like set it in the settings, like properly, like connect to your infrastructure, etc., etc. From the workflow perspective, it's pretty simple. You just add self-hosted. So here we have the example that we had. The first one with the injection, quite simple. What's the difference here? The difference now is that this workflow is executed not on the GitHub, but on your server, or the server of the organization that you want to hack. So, and now the impact that we were talking before, the first one, just the fact of executing code, is much more significant. It's much more important. Now you have like a entry point into your system, depending, of course, on how infrastructure works. But now the fact of executing code is very important. What is the mitigation here? So the GitHub says about self-hosted runners that please use it only for private repositories. Don't use it like for public, because potentially there is a risk of running arbitrary code. There is plenty of research, very good research. I leave the links here about it, how folks were like able to exploit it. Some use it for bug bounties, some use it for like some interesting outcomes. This one is kind of funny because the last one, because a researcher found a vulnerable self-hosted runner on the GitHub organization. So the GitHub has the GitHub organization on the GitHub, and they had a workflow that was public, but running self-hosted, and it was vulnerable. So despite the fact that they ask, please don't do it, sometimes people need to do it. Yeah, we always have edge cases. What to advise here? Honestly, I think that there is no silver bullet. Either like if you use self-hosted runners that potentially can be exploited, or you have on-prem version of the GitHub and you worry that somebody can get into your workflow and run code on your infrastructure. In this case, you need to be aware of this, and you need to take measures depending on like how would you protect your infrastructure in like case of having such entry points. So it depends on your risks, your measures. So yeah, and it's like it can be like a separate presentation and like goes beyond the scope of this talk. But well, I would say at the very minimum, you need to be aware of this. Yeah, and try to mitigate the risk. What should we learn from this part? Self-hosted runner means GitHub Actions are executed on the company server. Executing code inside action means executing code on the server, remote code execution in this case. Well, the mitigation will be don't use it. Yeah, if you can. So, all right. If there are more questions, let me know. All right, feel free to type more questions. I'm switching to another part. So, some hardening advices. What they are. So we talked about this today. I would advise always set permissions to read only everywhere, and then graduate it when needed to a specific permission. Like if you need like to write to pull request, have like pull request write, like only depending on the activity that you do, but always try to like set the permissions to read only. It will mitigate a lot of like risk. As we talked previously, try to keep the input inside the environment variables instead of injecting them to this like string values of the parameters. Isolate steps that work with submitted code, like third-party code, into a separate job with like minimal permissions. Also, there is another thing. When you have an organization like GitHub organization and you create new repositories, by default, it inherits the parameters, some global parameters from your organization. And there is one setting that is called allow GitHub Actions to create and pull requests. There is a link to documentation of it. So basically the idea is that it will allow the like the GitHub token from the workflow to have the permission to create and approve pull request, which basically allows a person who can acquire this token to create, like to submit any kind of code. You can submit the code and then approve it, and it will end up in the code base. So, and you don't want that. By default, this setting is false. However, for organizations, sometimes they set it to true. So just double check, yeah, and be aware that like to make it, to keep it false, so that workflow didn't have opportunity to like submit the code and inject whatever malicious code into your system. Another advice, there is a good feature, branch protection rules, also to protect from the attackers potentially injecting code in the code base. Such branch protection rules, you can also see the link. For the documentation, they allow you to do such things as, for example, require pull request approval before merging, require multiple approvers for the PR before merging for a specific branch, require those approvers to be actual code owners. So it can harden the important branches of your code base and not allow, because you, in a situation when, let's say, you have a workflow that can potentially do it, it will still not be able to do it because, let's say, if it's like GitHub token is allowed to approve pull requests, but if there are like 3 approval required, it still will not be possible, and you will see that something strange is happening. So yeah, it's a good thing. Please use it. Also, my advice would be try to avoid organizational level secrets. It means that you can define secrets on the level of organization and on the level of the repository. And when, let's say, repository like workflow was compromised, there is injection, you can run whatever code, potentially attacker can extract secrets that are supplied to this repository, and it will be repository level secrets and organization level secrets. So by avoiding like a global organization level secrets, you can like limit the potential impact to only those that are accessible to the particular repository, and try to like only provide those secrets that are really needed for this particular repository. Yeah, this can be also a good practice. Okay, so also, you know, like when you harden your workflows, you also want to be like proactive and try to find vulnerabilities. You can do it with Semgrep because luckily, as I showed you today, all of this is mostly YAML configuration. It's quite easy to scan with static analysis tools. We have set of rules specifically for GitHub Actions. They are also part of the default set of rules that we have. So feel free to install the open source version of Semgrep, run it, find vulnerabilities. We also have the community sending some improvements and their own rules for GitHub Actions. I try to create it, and I see that like, yeah, many new research pop up. We add new rules, so yeah, feel free to use it. Also, as a little bonus before we finish, so I mentioned at the very beginning that we're gonna talk only about like the one part of the attack surface today, and this is true, but I wanted to mention that, of course, the supply chain risk of potentially compromised third-party dependencies is very high risk, and it also can happen. Like recently, there was a TJ Actions changed file compromise. It was a big deal. It was in all social networks, media. You probably heard of it. And Semgrep team provided a rule for finding such vulnerable action in the code bases of our customers or users or people who wanted to use it in their system. I provide this link because, well, more and more research is done on this topic. More and more eyes are looking into this potential threat, and I believe that in the future we can see more cases like this. And what you can do, you can use this rule already existing as a template. And let's say if you want to find the vulnerable action maybe that you identified for your organization, or something new pops up in the media you want to protect, you can take this. It's quite simple. If you omit the data, I don't know, because it's specific to this vulnerability, you can, if you look at the pattern itself, it's quite simple. You can change the name of the action and the version here. Here in the playground, it's free to use. By the way, you can have a test cases to test that everything works as you want. Yeah, and if another such things pop up, you know what to do. You can use Semgrep and use this thing as a template. Yeah, that's what I wanted to mention. Thanks for listening. I use a lot of references for this presentation, for this talk. You can use it too by downloading the slides with this QR code or using the link. Yeah, I'm ready to answer your questions if you have some.
We actually just got one question in the Q&A. It says, is there a difference in Zizmor and Semgrep?
Well, yeah, Zizmor is a new tool for specifically dedicated to GitHub Actions. It's a new one. I would say the main difference will be that first of all, that Zizmor is dedicated specifically to GitHub Actions, and that how to say it, like Semgrep, Semgrep is a universal tool where you can write rules and add new rules easily, while Zizmor is a single tool that is dedicated to one thing specifically. Probably at this current moment, it can find a little bit more vulnerabilities than Semgrep, but let's say if something new pops up or you want to adopt it to your system, you would need to modify the tool, right? And it can be quite hard. But with Semgrep, it's more useful because it's more universal, because you will need to write add more rules, write one more YAML rule to the set of rules that you use. So that would be the difference. Okay, yeah, thanks a lot for listening. Feel free to reach out. You can use public Slack that we have. You can reach out directly to me. This work is going on. Probably we'll share more materials on GitHub Actions later. So yeah, thank you very much.